Good morning, fourth grade. Today we are doing lesson 2.3E. This can be found in your teacher's manual, pages 98 and 99. Today we're talking about estimating when we divide decimals, and we're also talking about terminating and non-terminating decimals. Let's think about estimating first. If I have 428 and I need to divide that by 6, we need to be thinking here about what our answer should be about. And you can follow along right with me. If you want to pause and go get something to write on, go ahead and do that. Okay, so when we have 428 divided by 6, if we rounded this number to the nearest tens place, we would look at the 2 and we would say, okay, it's either going to stay or go up. And in order to know, we would need to look at the place value next to it, which is an 8. The 8 tells us that we would need to go up. So when we round 428 to the nearest 10, we would get 430. And we might give ourselves a little pat on the back and think, that's so great. I know how to round that number. 430 divided by 6. Now what? Because that doesn't actually really help us too much in thinking about what the answer would be. This is the difference between estimating and rounding. And we've talked about this before, but I just wanted to remind you that when you round, you only can stay at the number or go up, and the next smallest place value determines that. When you estimate, you have a little more flexibility. We could stay at the number, meaning we could make this 42 tens if this 8 was smaller. We could go up like we did with 43 tens, but you could also go down even if this 8 is there. Estimating gives you a little more freedom, and it allows you to quickly come up with an answer. So let's do that. Let's pretend this 8 isn't here, and instead of rounding this and knowing that that's 43 tens, let's make it 42 tens. 42 tens divided by 6, in your brain you should be thinking, oh, I know that 42 divided by 6 equals 7. So 42 tens divided by 6 equals 7 tens. And here's our number bond, 42, 6 and 7. So 42 tens divided by 6 is 7 tens, because my class knows when you divide puppies, you get puppies. So when we divide tens, we get tens. This will help us when you're thinking about estimating. It's really helpful to be able to go back and forth between rounding or being a little more flexible and using what you know with your number bonds. So we know that 428 divided by 6 should be about 70. It's important that you estimate before you start your division, because it's easy to mix up your place values, and that really impacts your answer. Now, I'm going to erase this, and we are going to actually do this division problem. So go ahead and get a piece of paper or a marker board, and we're going to do 428 divided by 6. You're going to need some space at the bottom. So make sure you have lots of room to go down. This is actually the second video of this lesson I've done because I did not leave enough space for myself. All right, here we go. We're going to start with our tens because we don't have enough hundreds to give every 6 100. So we need to think of this instead as 42 tens. 42 tens divided by 6, or put into 6 groups, means that we could put 7 in each group. Because 6 times 7 is 42, we've actually used all of our tens. We don't have any left. And now we're going to bring down our ones. Now we have 8 ones left. And we can say if I have 8 ones divided into 6 groups, I could put 1 1 in each group. I would use 6 of those 8 ones, and I'd have 2 ones left over. Hopefully you're following along. You're with me so far. Now, before yesterday's lesson, you would have said, oh, the answer is 71, remainder 2. And if you remember what our estimate was on the last screen, we thought it should be about 70. So that's pretty close. So far, so good. But now that you know about decimals, you know that we don't need to stop there. So we're going to add a 0. This hasn't changed the fact that we're still doing 428. We're just showing that we understand that when we add a decimal point and a 0, it doesn't change the value of the number, but it does help us to think about what the remainder is. So instead of thinking about this as just 2 ones, we can now think of this as 20 tenths. If I had 20 tenths, so 20 of these guys, and I divided them into 6 groups, I know I could put 1 in each group, and I would have used 6. I know I can put 2 in each group, and I would have used 12. I know I could put 3 in each group, and I would have used 18. If I put 4 in each group, I would have used 24. So I need to put 3 in each group. So I'm going to pop my decimal place right up there. I'm trying to keep my numbers all lined up. I'm going to put 3 in each group, and I actually need to make my line longer. And 6 times 3 is 18, so 6 tenths times 3, so 6 times 3 tenths is 18 tenths. If I had 20 tenths and I took away 18 of those tenths, I would have 2 tenths left over. Oh, we still have 2 tenths. I guess we're going to have to add a 0. Okay, so we'll just add a 0 here. Now, instead of calling that 2 tenths, I'm going to actually call this guy 20 hundredths. Okay, that's fine. 20 hundredths divided into 6 groups. Well, I've basically done that problem. So, but now instead of tenths, oh wait, I'm going to make this eat. Ready? Eat it. Yes. Now I've got 20 of these, 20 hundredths. I'm going to put 20 hundredths into the 6 groups, and I know that 3 hundredths times 6 is 20 hundredths. So I'm going to go ahead and I could put 3 in each, and I would have used 18 hundredths. And I would have 2 hundredths left. Shoot. Well, I have 2 of these guys left over here, and I still have 6, and I can't do a remainder, so I think I'm going to have to add another 0 and bring this down. And now I'm going here, you can say eat it, eat it, eat it, and we'll make him eat it. Okay, now I've got thousands. Okay, now I have, instead of calling this 2 hundredths, I'm going to call this actually 20 thousandths. I've got 20 thousandths. Okay, I know about 6 and 20. We've been doing this for a while. So 20 thousandths divided by 6, I should be able to put 3 in each group. Okay. And then I would have used 18 thousandths, and I would have 2 thousandths, 2 of these left. Do you all see the problem here? Do you notice that we have 2 left, and then 2 left, and then 2 left, and then 2 left? We literally could go on forever renaming and renaming and renaming our decimals, and we would never get a final answer with this number. That's because this number is called, this quotient at the top is called that means not terminating. Say that word, terminating. To terminate means to end something. So if I was a foolish parent and decided to cancel our Disney Plus subscription at this point in the world, I would get an email from Disney Plus saying, your subscription has terminated. That means it's over. Or if I'm driving down the road and there's a roadblock, I would say that the road has terminated. Like there's no way to go forward, it's the end. This is non-terminating, meaning it will never end. And we're just going to stick a little line above there. And that shows us that this would go on forever and ever and ever with 3's at the end. So that is a non-terminating quotient when we are dividing decimals. Now I would like for you to pause and you try. I would like for you to open your textbook, and I want you to do textbook. This should work. Textbook. Here we go. Page 59. I would like for you to do number 18. Cover up the little friend on the side who's giving you the, telling you how he's thinking about the estimating. I want you to do 19. And then I want you to do 23, problems A and E. And I'll show you the answers to 23A and E when you come back. That'll be a second video.